doesn't pick up noise from very far, so unless you're super loud, it mostly only picks up me. All right. This is, okay, inverses. I have a little bit of a warm-up question, but can we just review really fast what an inverse means? And then you get the y by itself. Does this look familiar? And then we replace this, if we had function notation, with this notation, right? This one was f of x. Okay. Do you remember doing this? They were supposed to cancel each other out if you put one inside the other. So I won't do both of them. But if I took this one and put it back in the original one, I'd have 2 times x minus 3 over 2 plus 3. These would cancel, and I'd have x, right? Okay. So inverse, one more thing. How did you know if you could put this notation on it? Do you remember? If the inverse was also a function. And how did you decide if something was a function? Yes. So when we do sines and cosines today, is this going to pass the horizontal line test? No. Okay. All right. That was the preview. Now, the actual warm-up question really fast. This is off yesterday's homework, and I didn't get to this at the end of the lesson yesterday, so I promised I would talk about it today. The last 2 questions on last night's homework, I'm sure you all did these, graphing tangent, cotangent, secant, and cosecant. And then these were left, and these are solving by graphing on the calculator, which you probably, if you happened to be one of the 3 people in the whole school who did their homework, saw this question and it said calculator, and you knew that you needed to use your graph calculator, okay? So it says this. What does that mean about our graph? Yes, so our x, max, and min are going to be pi and negative pi. That makes sense now? But we need to talk about how to type that in. How do you type cotangent in? No. It is 1 divided by, it's reciprocal. So you're going to type 1 divided by tangent for y1. That's what I did right here. Can you see it? Okay. Now, we talked a little bit about this yesterday because someone asked a really good question. Maybe Joshua, I don't remember. But when you do a reciprocal, he said, why isn't this all 1 over, right? And so that became 1/2. But that's not what it means. What this means is 2 times the secant, which is 1 over cosine, okay? So you could type it that way. I just did 2 divided by cosine. Same thing as 2 times 1 over cosine, okay? So I put those both in. Now it says, where are they equal? How do I decide where, okay, what mode did I have to be in? Radians, okay, because I'm graphing. How did I decide where they're equal? Yes, I find the points of intersection. Okay, I think I have it on my handy dandy calculator here. And so I did second intersect or second trace, found the intersection point. This is one of the intersection points. Okay, what does that mean is an answer to my equation over here? Oh, stop, go away. If this is an intersection point, what is an answer to this equation? When we used to say, I don't know how to solve this equation, let's do this. I don't know how to solve that, maybe. So we would set this in y1 and this in y2, and we'd find where they intersect. And we were looking for the x coordinate, yes? Okay, so we made this x when we typed it into our calculator, and this x. So if this is a point of intersection, what we're looking for is this x value. Make sense? Mm-hmm. And there's another one over here, yes? think it's 0.7 something. Did someone find the other one? Okay, let me see your calculator. Probably something typed in funny. Anybody find the other one? Is it 0.7 something? It says error window range. So that means you need to go here. It should be negative pi and positive pi. You have them backwards. Is it 0.7 something? Okay, we'll just keep going on the lesson then. No one's going to do it. Okay. Second, trace, intersect. I got 427. Is that what you're getting? 0.427. I don't know where I got 0.7 something. Okay. All right, so you get how to solve those two questions. I just did 37. You still have to do 39. All right, so today's lesson is on inverses of sines, cosines, and tangents. It says here, we learned about inverses, and we just talked about that. And we learned that the inverse function is a function if and only if our original function is 1-to-1 or passes the horizontal line test. The sine function does not. Okay. Now, before we go any further today, I want to spend 1 minute talking about the difference in these. This is the lesson today. What is the inverse sine of 0.5, which is 100% equivalent to what is the arc sine of 0.5? Okay? These are just different notations because some math person always finds a way to make it harder than it has to be. So they decided there's two different ways we can write the same thing. Okay? All right. How many answers are there to this? If I ask you what is the sine of 30, look at your unit circle. What's the sine of 30? Okay. The sine of 30 degrees is 1/2, right?
Yes.
Okay. It has a single value, yes? Okay. Back in geometry, when you had this equation, you typed it into your calculator and it gave you one answer. It gave you 30 degrees or pi over 6, depending what mode you were in, right? Or a decimal equivalent. But if I gave you that equation, I need you to understand that there are infinite solutions to that equation, and we're going to spend time on that later, not in this section. But look at this graph. The blue is the sine. The red is the line y equals 0.5. Do you see that that line crosses over and over and over? And if I were to continue it, cross over and over. Matter of fact, on your unit circle, there's two places that I get 1/2 for a sine. Do you find the other one?
150.
Okay. Pi over 6 and 5 pi over 6, right? And does anybody remember how we said all coterminal angles with that? Plus or minus 2 pi n. Okay, that's the next chapter, but this is different than this. This has only one answer. All right, so I want to talk real quick about the graph, but I'm going to give you an upfront heads up that I'm not going to make you graph these on a test or quiz, all right? When the sine function is graphed, it repeats and it doesn't pass the horizontal line test. So we have to restrict it so that it will pass the horizontal line test. Do you remember one time we did this and we said, what could I restrict so that this was 1-to-1? And we said, well, you could say we're just going to keep this half, or of a parabola. We did it one day. I don't know if you really remember, but so they restrict this. Why did they not pick like 0 to pi for the restriction? Because it still wouldn't pass the horizontal line test, right? Why didn't they pick 0 to pi over 2? Just that little piece. Okay, good job. So what they did is they restricted it as close to the origin as they could, where it would cover all the values from -1 to 1. So they did from what to what? Where are those two red lines? Okay. An inverse means we not only switch the x and y values, what happens to the domain and range? The domain becomes a range, the range becomes a domain. So look what the graph looks like. Where this used to go negative pi over 2 to pi over 2, that's now the range up and down. And it used to go up and down from 1 to 1. It now goes across from negative 1 to 1, okay? Now, I'm not good at drawing this, so we're going to go here, and I'm going to attempt to sketch it, but I'm going to put that picture on the screen so that I can do a better job. So it's been restricted in here. You have this on your notes, guys. This is in front of you.
Oh.
It's been restricted there. So we're going to go over here and sketch the inverse. And all we want to do is write that it goes from negative pi over 2 to positive pi over 2. And it goes from negative 1 across to 1. That's good enough for me because I'm not going to have to get a graph it anyway. It's now 1 to 1 though, okay? Now, I want you to think about that. If we're looking for values where the sign is from positive pi over 2 to negative pi over 2 or negative pi over 2 to positive, what quadrants is that? Are those? 0 to pi over 2 is quadrant 1 for sure. Where's negative pi over 2? Okay. So we're going to go quadrant 1, but we also have to talk about this in quadrant 4. So take your marker and make yourself a little key that says the inverse sign I'm going to do in this color. And I'm going to tell myself I need to look only in quadrants 1 and 4 for an inverse sign or an arc sign solution. You will get to use this colored unit circle on the first quiz. After that first time, you're going to have to use your pink sheet. The pink sheet isn't going to have it colored and renumbered for you. It's going to have the domain and range listed at the bottom. And I'm going to show you that. Okay. Everybody get theirs colored? Okay. So the answers for an inverse sign question can be 0, pi over 6, pi over 4, pi over 3, pi over 2, or anything along the way in between in theory, if we weren't looking for a special right angle, a special right triangle. But down here, we can't answer 0, 7 pi over 4, what else is down there? 11 pi over 6. We can't answer those because what did the restriction say? It had to be between negative pi over 2 and positive pi over 2. So what I did is I erased these for you so that we could renumber it. What are you going to call this one? Good job. And this one is negative, and then negative, and then don't forget this 270 is now negative pi over 2. Okay? This is going to be really helpful to you to remind you to call them by those names. I need you to look at your pink sheet. On the pink sheet at the bottom, do you see at the bottom of the pink sheet underneath the unit circle? You don't get a colored unit circle for the final. What you get is this that says the inverse sign is restricted to this range, negative pi over 2 to pi over 2. That's your reminder that when you look at the unit circle above, you need to look between those. But your unit circle isn't going to be renumbered, right? So you're going to have to remember if I'm in quadrant 4, I got to call it the negative name. Okay? All right, now what am I talking about that you're even going to use it for? Well, let's practice a little bit. It's going to ask questions like this. It's going to say the arc sine of square root of 3 over 2. Arc sine is looking for an angle. So where is the angle? Okay, but it has to be between negative pi over 2 and pi over 2, which means it's got to be in radians. Okay, where am I looking for this number to be? yes, it's going to be in quadrant 1, but I want to see this exact number in which spot here. Why do I know that? Yes. All right, so I go to my unit circle and I find that in a sign position that's colored red at pi over 3, and I write down pi over 3. I'm skipping B for a second. Part C here says arc sine of -1, so I'm looking for a -1 in that position. I go to my unit circle, I go down here, but I don't call that 3 pi over 2, I have to call it what? Negative pi over 2. Do you see how easy this is? We're just using the colored circle to find the angles. Seem okay so far? Okay, now they're going to mess with your mind. For some reason, the book put a whole bunch of questions on here that are not possible. This is one of them because this is saying, yes. This is the answer because this means I'm looking for an angle. Find the angle whose sine is -1. Find the angle who, just like you used this back in geometry because you did inverse sine of 3 over 5 to find the angle theta. Now is it coming back to you? We're finding an angle. That's what this means, okay? Does that help? All right, guys, back to this question. They're going to give you a whole bunch that don't work. Can anybody tell me why this is not possible? I'm just going to change it to a decimal for a minute. Find an angle. In words, this means find an angle whose sine is -6. Can you envision the sine graph for me? Does it ever hit -6? No. It only goes between -1 and 1, so this is not possible. The book apparently gets off on that because there's a whole bunch of not possibles, okay? All right. Cosine. Here's the cosine. Is this 1 to 1? No, we have to restrict it again. This time, negative pi over 2 to pi over 2 doesn't look like a good plan, right? What do we want to restrict it to this time?
0 to pi.
0 to pi. Okay? I am going to paste this guy over here so that I can draw it a little better. I'll try to draw it freehand, though, just so that you're doing the same thing I'm doing. We're going to restrict it from 0 to what did you say this value was right here? Pi. So those are going to become the y values, okay? And the x values are going to be from the range over here, which was -1 to 1. So it looks like this. All right, I'm not going to make you draw those. The book had a bunch of assignments like draw 4 arc sine, draw -1/2 arc sine, draw, and I'm just like, why? Okay, Miss Gupta said we don't need them for calculus, so I'm going with it. I left off the colored unit circle. Okay, here we go. What quadrants? Thanks. What quadrants? If it said 0 to pi, 0 to pi, 1 and 2. So quickly color a second color and put a little answer key up here that says this is arc cosine. So when I look at my color coding, if it's an arc cosine or inverse cosine question, I'm going to remember I can answer anything between 0 and pi. That seem okay? So if I said, where's the cosine negative square root of 2 over 2? Negative square root of 2 over 2. Remember, I'm talking cosine now, so I'm looking at the x coordinates, right? Yes, 3 pi over 4. They're going to always answer in radians for these. Okay? Everybody got it colored? Okay, can you go to your pink sheet again real fast? At the bottom of your pink sheet, this is what it will say. For inverse cosine, it says, remember, you can only look between 0 and pi. Remember, I'm going to hand you the day of the final, the day of the quiz, whatever. I'm going to hand you a pink sheet, or it's yellow, I think my extra copies are now. And you're going to have to use that to determine which quadrants you can look in. All right. Going back here, we're going to practice this. Okay, using the unit circle, I'm going to do this. Okay, here's my pretty unit circle. So, where is the cosine? Negative square root of 3 over 2. So I go here, cosine, I can look in these two quadrants. Over here is where it's negative square root of 3 over 2 because it's got to be in the x slot. So it's 5, 6. 5 over 6. I don't know what I just said. I'm going to do C next. Okay. Inverse cosine of negative 1/2. So I go back here. It's cosine. It's still negative. So it's in that quadrant. 2 pi over 3. We good? Why did I skip this one again? Can't. It only can go from 0 to negative 1, or from 1 to negative 1, right? So this is not possible again. You could just write not possible. It's not. If it was just 0.5? Okay. If it said, okay, the question is, what if we change the question? So it said that our cosine is 0.5. Then I would, yeah, it's the same. Okay. So then I want to know where the cosine's 1/2, and it would be here at pi over 3. And that would be my answer. Okay. Arc cosine, cosine negative 1 mean the same thing. Say that again. For 2.5? There isn't one. Yeah, okay. All right, tangent. Tangent graph is sweet because it's pretty obvious how we can restrict this, yes? Remember yesterday we learned tangent graph? It looked like this, right? Hofbauer's were more curvy than this one probably, but it looked like that. There's asymptotes. Won't those work as our restricted values?
Yeah.
Okay, so we're going to restrict it to here. So the restricted value is going to be negative pi over 2 to pi over 2. But there's a problem. It has an asymptote, so can you ever actually say pi over 2 or negative pi over 2? No. Look on your pink sheet. Do you see the difference? What's different on the pink sheet between this one and sine? Yes, this is including, this is not, okay? This is including the answers. I'm probably not going to put that on a quiz for tangent, okay? But if I could ask you, the reason is, what is the tangent at pi over 2, guys? What's the tangent right up here, y over x? You're right. Y over x, 1 over 0 is undefined. Okay, so it would be kind of weird. It would be kind of weird to see this question. Yes? Okay, you can't do that. All right. So on my color, well, first, let's finish sketching this super fast. It looks like this. Okay. It used to go negative pi over 2 to pi over 2. That's now where the horizontal asymptotes would be. Does it have ends out here? This has a domain of all real numbers, yes? Because the tangent can be anything. The inverse tangent can be found of any number. Do you remember we talked about it as slope? The slope can get really steep, right? Doesn't have to stay less than 1. The graph had arrows here, even though this one didn't. So arctangent we can find of any number, but the answers will all between what two numbers? Okay, so here's my question. On my unit circle that I colored somewhere here, pi over 2 to negative pi over 2. What quadrants? Okay, I already have those colored, yes? You could use a third color, but I don't usually bother. I just say this is also the keyed color code for arctangent. Does that make sense, guys? Same two quadrants, sine and tangent. Why can't I use those two for cosine again? Look at the cosine values in those two quadrants. They'd all be positive, right? That won't help. All right, everybody got their unit circle colored? Okay, tangent is honestly the hardest one for me to explain and for students to understand. Let's just practice finding tangent on the unit circle for just 1 second. Okay, find me the tangent here. What is the tangent right there? This is not the color. Here, I'll use the quadrant we don't even ever talk about for this. What's the tangent here? Y. Yes, y over x, which means this, which is square root of 3 over 3, yes? Okay, guys. Tangent here. Gobbledygook over the same gobbledygook could be 1. Tangent here, y over x. They're both negative, so it would just be square root of 3, okay? All right, I just wanted to practice that because now this is the question. Where is the tangent? This, and it's negative.
Negative
Arctangent is going to be in these two quadrants, right? I need an ordered pair that's going to give me... Okay, hang on. This is exactly what happened this morning when I got... Okay, I'm looking for an ordered pair. It's either this one or this one, yes?
It's bottom one.
Okay, now, can you guys just give everybody a second to process, okay? One of these spots, does that make sense? Because those are the kinds of numbers we're looking with square root of 3s. Good, there, Sierra? Okay, so it's one of these ordered pairs that's going to give me this answer. If I put y over x here, I'd have that. If I put y over x here, I'd have that. Which one will simplify to this? Because this would just be negative square root of 3. But this one I'd have to rationalize. So it's at this spot, which was 11 pi over 6, but we renumbered it to... Do you see it now on there? Sierra, you with me? Okay. Where is the tangent negative 1? In our colored quadrants. Okay, look guys, if I go up here, y over x is undefined. If I go down here, y over x is undefined. How do I make it a 1? Yes, pi over 4 is 1. Negative 1 is at negative pi over 4. I told you tangent is tricky. So negative 1 would occur at negative pi over 4. All right, here we go. We're going to practice. I am going to skip to this. This is actually 20b, right? Okay. All right. This question. Okay, so the question is, come on, where's the tangent 0? Where is the tangent? 0. Okay, so if I put 0 over 1, I would get 0 for tangent because it's y over x. So yes, it's 0 radians. Going the wrong way. Come on. Okay, number 2. Where is the sine square root of 3 over 2? Sine positive square root of 3 over 2, pi over 3. This means the same thing as this. Is that helpful? So you're finding an angle, okay? Those are equivalent. And the answer was what again, guys? Pi over? Thank you. No. Cosecant is a reciprocal. In inverse is undoing it and finding an angle. Totally different. Okay. Where is the cosine? Positive square root of 2 over 2. Everybody okay? Okay, where is the tangent? Negative 1. Tangent is tricky.
Negative.
Because remember, you got to do the y over the x. Okay, 7 pi over 4 is it. The tangent there is negative 1, but is that in my range of values I'm allowed to say for inverse tangent? He's using his pink unit circle, which is what he's going to have to do on the quiz. On the pink unit circle, I go down there and I go 7 pi over 4 is where it's negative 1, but I can't answer 7 pi over 4 because it says at the bottom of the page, what? It says inverse tangent has to be this. So what can I call it instead of 7 pi over 4? Okay, you're not wrong. It's just not part of the... Yes. Okay, number 5 is a typo, guys. You can't have both the little negative 1 and the arc. It doesn't work. It doesn't undo each other. It does nothing. It's wrong. So where is the sine? Negative square root of 3 over 2. I go to my circle. The sine, which am I looking for this time? Yes, it's sine, not cosine. So it's down here at negative pi over 3. We good? Okay. Where is the sine negative 1/2? Okay. Where, uh-oh. What is this asking? It is asking for the actual tangent at negative 3 pi over 2. This is not an inverse question. They just threw it in there. This was on the last quiz. Okay. Right? You had to use your unit circle to find me the tangent? Okay. So looking at your pink sheet, 3 pi over 2. Uh-oh, negative means I'm actually at the top of my unit circle, right?
Oh, so we're at 4 pi over.
Joshua, where is negative 3 pi over 2?
I don't know where.
No. Three pi over 2 is down to here. Negative 3 pi over 2 means I went around to here. So this is where I am. I'm not doing anything weird. I'm just there. So I'm at the ordered pair 0, 1. What is the tangent at that spot? It is not.
I'm aware of something. What? You go pi over 3.
There's no 2 pi over 3. It's 3 pi over 2. That's what's messing you up. Okay, moving on to number 8, guys. Shh. Where's the tangent? Negative square root of 3 over 3. Tangent is hard. It's got to be negative. And it's going to have to be this, right? So when I put the y over the x, I get this, which is negative square root of 3 over 3. And where is that happening? Okay. This should have parentheses. Are you going to find this in quadrant 4? Okay. Inverse cosine is blue. I'm looking for an x value that's negative 1/2, which is happening over here, yes? I don't know what happened to my cursor, but it's happening at, okay, please work. All right, what about this? The sign can never go above or below 1 or negative 1. Yep. Okay, now we get to another part of this, another component of inverse function. Do you remember earlier today at the beginning of the lesson, I talked about how if you put one into the other, it should cancel it out and become x, okay? So what that is saying is, if I do this, the answer should be this, okay? And that's true, but it's only true sometimes. Because let me show you a place where it's not true. Can anybody tell me why that's not true? Yes. 7 pi over 4 has a cosine. If I look on my pink sheet, I go to 7 pi over 4, the cosine is square root of 2 over 2. The inverse cosine of square root of 2 over 2 has to fall between negative pi over 2 and pi over 2, and its answer is pi over 4, right? Where's the cosine, the x value, positive square root of 2 over 2, is that pi over 4? Okay. So they didn't undo each other. Now, this is the book's idea. Here's all the places where they will undo each other. And so you have to figure out if it falls in this range, if it's one of these functions, or in this range, if it's one. No. We're just going to do it like a function. I'm not going to memorize all that. When we did this, we put a 2, say, into G, and then we put that answer into F, right? We worked inside out. That's all we're going to do. We're going to work inside out, see if our brains can handle this. Okay. I'm skipping 11 on purpose for a little bit. I'm going to start with 12. Okay. The cosine at pi over 2. Go to pi over 2. What's the x value? 0 is the x value, right? Because cosine is x. Now, the second part says work backwards. What angle has a cosine of x? Of 0. Sorry, cosine of 0. No. What, yeah, did I say it? I didn't make it clear at all. What angle has a cosine, we're in blue now, of 0?
Oh my God.
Pi over 2 or 90 degrees, we have to answer. Okay. These did undo each other, right? But they don't always. Okay, let's look at this one. Tangent 3 pi over 2. There is a tangent at 3 pi over 2. What is the word we write? Undefined. And what did we just discuss earlier? Can you do the inverse tangent of undefined? Why not? Because if I did, I would want to answer, okay? I would want to answer that the tangent is undefined at, let me find this slide again. Okay. Yes, the tangent is undefined. Look, at negative pi over 2 or positive pi over 2, but are either of those included in the range of answers I can give? No, they have soft parentheses. That's why it doesn't exist. Okay. Ooh, where am I at? Too many slides. Okay, let's try, 14. Is this going to undo each other? I think not, because it's not even the same function, right? Okay, what is the cosine at pi over 6? If I go around to pi over 6, the cosine is the x value, and the answer is? Okay, now I'm doing an inverse, so I want an angle whose y value for sine is square root of 3 over 2, and I get, good? All right, this is a totally different situation, and we're going to do some more of these tomorrow. This actually exists because negative 3/4 is something I could find an angle for. It's just not a pretty answer, but the answer to this question is pretty because arc sine is in which two quadrants? 1 and 4. It's negative in, so somewhere in this quadrant, opposite over hypotenuse looks like this, right? Okay, I want to know the sine of that angle. I don't want to know the angle, I want to know the sine of it. After I've figured out that it can exist, its sine is, they do undo each other here.
What? All right.
I could have typed on my calculator second sine negative 3/4, and it will give me negative so many decimal point because it's in radians. But then I want the sine of that. So I'm just going to go back, and it's going to end up at negative 3/4. All right. We'll do more where we draw tomorrow. Arc sine of 1/2. Where is there a sine of 1/2? What is the cosine at pi over 6? Good job. Okay. Where is the sine? Negative 1/2. What is the tangent at negative pi over 6? Y over x would be this, yes? So it's negative square root of 3 over 3. Everybody okay? All right. Where is the cosine 2? Nowhere, right? Where is the tangent negative square root of 3 over 3? We've done that one like 6 times today. We just did it right up here, right? It was at negative pi over 6. So now it says, what is the cosine at negative pi over 6? We can't do arc cosine down in that quadrant. We can find the cosine. What's the cosine right there? All right. What is the cosine at plain old pi over 3? What is it? And where is the sine 1/2? Okay. What is the cosine at pi over 3? And where is the cosine? 1/2. That one's just going to cancel it out because it's in the first quadrant. All right, let's try 22. Where is the tangent negative square root of 3? You're looking for y over an x like this. Nope. You're in the wrong quadrant. Nope, you're in the wrong quadrant. Negative pi over 3, right? And what is the sine down there at negative pi over 3? It is? Isn't it? Sine is y value. Square root of 3 over 2. Hey guys, if you need a copy of the bookwork, there's some up here by the blue basket. Get this done this weekend. I know it's more than 10 questions, but that's because there's nothing to do. You're just going to circle and write down the answer. Yeah.